Hello, everybody. Today starts the first day of our brand new section, 3.2. The title of our board notes is going to be Solving Power and Root Equations. Solving power and root equations. We're going to have a goal. Our goal for today will be to isolate the term that contains the power or root, and then raise both sides to the inverse. And we'll see what this means as soon as we get into our examples, but let's write it down first, okay? Our goal will be to isolate the term that contains the power or root, and then raise both sides to the inverse. Now, there are two parts to our notes. First, we're going to talk about raising both sides to an even root. Recall from our last section, when we have a to m divided by n, this is my power, this is my root. So we're talking about if something is raised to a value and the denominator is even. We'll get plus minus. I'm going to keep it simple and I'm just going to put that. We'll get plus minus results. A very, very simple example of this is when you are solving, for example, x squared equals 16. To solve this, you need to take the square root, or in other words, raise this to the 1/2 power. That is an even root. This is not typically how we would draw a square root, but that is really what this represents. Square root, an even root. And as soon as we did that, we would get x equals plus or minus 4. This is that result, that positive and negative result I'm talking about. Okay? So we need to keep in mind that when we raise both sides to an even root, meaning the denominator of the rational power is even, we're going to get a positive negative result. The other piece we need to talk about is raising both sides to an even power. Raising both sides to an even power. Oops, I want to make that a different color. Sorry. I'll make it blue. Because I want you to see it as different than what we just talked about. Because now we're talking about the numerator, the m as in Mary, the m value. When raising both sides to an even power, something called an extraneous solution a new vocab word for us. Extraneous solutions can happen. this is an extra, see the word extraneous? Extra is kind of built in there. It's an extra solution that can arise that is not a solution to the original equation. So extraneous solutions can happen when we raise both sides to an even power. An extraneous solution is an extra solution that can happen that's not a solution to the original equation. So for example, again, we'll come back to a very straightforward example you're familiar with, you just didn't realize that it's extraneous, is if you were solving x squared, or excuse me, the square root of x equals -1. Well, to solve this, the opposite of square rooting is squaring. That is an even power. When I take the square root, or excuse me, when I square both sides, I get x equals 1. But this is a false solution. This is an extraneous solution. It's false because if you try to substitute this back into the original, right, the square root of 1 equals 1. There's no way you could get a -1 from that. That's what makes this a false extraneous solution. And that can happen when we raise both sides to an even power. So, always check if the original equation is an even root. So for example, from the outset, this was a square root. So if it's a square root, fourth root, sixth root, that would look like x to some even power here if this is even, the numerator. Always check if the original equation is an even root, because we possibly could get this extraneous solution. So that means that if in the process of solving you raise both sides to an even power, have to check answers. So if you raise both sides to an even power, you're going to have to check your answers, because it's possible that one of them, or the actual answer, sometimes when you solve you get one answer, sometimes you get two. One could be extraneous. So big picture here, okay? If you raise both sides to an even root, the n value, is even, we're going to get a positive-negative relationship, positive-negative answer. If we raise both sides to an even power, referring to m, the numerator of the rational exponent, we're going to have to double check, literally double check or check our answers by plugging them back in to make sure they're not extraneous. The best way to realize what all of this means is to practice. So now that we've laid the groundwork with our notes, let's practice. Examples. Solve is the directions. So let's solve. 1 is going to be x to the third equals negative 125. Put a line down our equal sign. To isolate x, we're going to do what you wrote, right? Isolate the term that contains the power or the root. Well, x to the third is already by itself. Raise both sides to the inverse. So what's the inverse of 3? 1/3. We're going to raise both sides to the 1/3 because 3 times 1/3 cancels out to 1. So now I have x equals, we should recognize 125 from our chart. We can rewrite 125 or negative 125 as negative 5 to the third power. And it's still being raised to the 1/3. I haven't actually done any math. All I did was rewrite negative 125 with a smaller base. 3 times 1/3 is 1. My answer is x equals negative 5. I never had an even root, right? 3 is odd. And I never had an even power because the numerator is 1. So there was no plus minus, there was no need to check. So odds of all kinds here are nice, okay? Number 2. Two says 1/2 x to the 4th plus 15 equals negative 113. Line down the equal sign. Now here, the term with the rational exponent or the power, right? Term that contains the power or the root, it's not by itself. So we're going to have to isolate x to the 4th first. If there's something on this side we can add or subtract, we need to do that first. What could I add or subtract? We can take care of this positive 15 by subtracting 15 from both sides. So that leaves 1/2 x to the 4th equals negative 113 minus 15. If you are using your calculator for solving, let's pause, go get your calculator if you don't have it. We're definitely going to be using it from time to time. I know that this is going to be negative 128. You're adding in the negative. So, I mean, technically you didn't need a calculator for that, but if you're going to use it, go get it. Now, to take care of this 1/2, we can multiply both sides by 2 because 2 times 1/2 is 1. So now we are left with x to the 4th, which is our goal. We wanted to isolate this term. Negative 128 times 2 is what? If you're using your calculator, type in negative 28 times 2, and we should get negative 256. The inverse of x to the 4th would be raising this to what power? My hint to you is that it's going to be a fraction. I'm going to raise both sides to the 1/4. And I do that because then when I multiply these powers, 4 times 1/4 becomes x to the 1st. The inverse operation. Here, notice this is an even root, 4th root. So let's take some notes on this. means fourth root of negative 256. Can you take an even root of a negative number? No, because you will get into imaginary solutions. So this has no real solution, or just no solution. Number 3. 2x to the fourth equals 32. We need to isolate x to the fourth. What are we going to do? Well, I know that this says 2 times that, so I can divide both sides by 2. We get x to the fourth equals 16. The inverse of raising something to the fourth power would be raising it to the 1/4 power. So let's do that. This is an even root. 1/4 is an even root, fourth root of 16. So I know I will expect to get a positive, negative answer here. 4 times 1/4 is just x. From my chart, I know that the fourth root of 16 is 2. So positive, negative 2. Whenever we take an even root, again, paying attention to this denominator, the denominator of the rational exponent is even. That's an even root. We're going to get a positive, negative. And as we're working, I'm always going to make this note, and I recommend it. Even if you don't write even root, point an arrow to this denominator and put plus minus with a little box. It'll help you remember to do that as we practice. If you only put x equals 2, well, that's only half right. There's 2 answers. X equals 2 and x equals negative 2. Number 4, x minus 2 raised to the third power, all raised to the third power, equals 10. This term is as isolated as it can be because it's all raised to the third power. So right away we can work on the inverse of that power of 3, which would be raising this entire side to the 1/3. What we do to one side, we need to do to the other. The 3 and the 1/3 cancel because 3 times 1/3 is 1. So we have x minus 2 equals 10. I don't want that in purple. X minus 2 equals 10 to the 1/3. And I'm going to ask that we work with a decimal solution here because we're working towards a single number as our answer. So in your calculators, 10 to the 1/3, the entry should be 10 caret parenthesis 1 divided by 3. Putting the 1/3 in parentheses is really important. Let's see what you get. 10 to the 1/3. Rounding to 3 decimal places, I got 2.154. Hopefully we match. No worries about evens of any kind. There's no even root or even power. So notice, no plus minus of any kind here. To finish solving for x, I'll add 2 to both sides. And I get x equals 4.154, and I'm done. Number 5. X minus 4 to the 4th equals 81. This is as isolated as I can get it, so I'm going to work on getting rid of this power of 4 by raising both sides to the 1/4. This is an even root, right? 4 in the denominator. This is the place where the root is. I'm going to draw an arrow to that 4 in the denominator and make a note. It's even more thorough if you write even root plus minus. But at a minimum, I would like to see you drawing an arrow to the denominator of the rational exponent and drawing a little plus minus in a box. So you remember to do that on the next step. 4 times 1/4 is 1. So I'm left with x minus 4 equals the 4th root of 81. So mentally, in your brain, you need to see this as the 4th root of 81. And from your chart and your awesome flashcards, we know that that is 3. And it's not just 3, it's positive or negative 3. From here, blast from the past, we're going to set up 2 little equations. X minus 4 equals a positive 3, and x minus 4 equals negative 3. Mental math, add 4 to both sides. This becomes x equals 7. Add 4 to both sides. This gets us x equals 1. And we're done. Number 6. 5 plus 3 times 2x minus 4 raised to the 6th power equals 197. Put a line down our equal sign. We're going to work on isolating this piece right here, this power piece, so to speak. So first, on the entire left side, if there's something we could add or subtract, we have to do that first. My attention is immediately drawn to this positive 5. I know that I can subtract that from both sides. (197 minus 5 is 192). If you're confident and you can finish this, go ahead and press pause and see if you can work towards the solution. A hint would be you're going to deal with that 3 next. See if you can finish it, and then we'll compare answers. Press pause. I'm going to divide both sides by 3. These 3's cancel. 3 divided by 3 is 1. So we get 2x minus 4 all raised to the 6th power. 192 is divisible by 3. We get 64. So now that this power term is as by itself as it can get, we can use the inverse operation, which would be raising it to the 1/6. I see even number in the denominator. This is an even root. I know I'm going to have a plus minus happening here. 2 answers are going to come out of this. So 6 times 1/6 is gone. I get 2x minus 4 equals mental bubble. I need you to see this not as 64 to the 1/6. Mentally, I need you to see this as the 6th root of 64. From your chart, the 6th root of 64 is 2. Because 2 to the 6th, 2 to the 6th power is 64. But it's not just a 2. Because you took an even root here, this is plus or minus 2. So we have to set up our little equations again. 2x minus 4 equals a positive 2. 2x minus 4 equals negative 2. If you didn't have the note about the even root and the plus minus, add it. If it helps to have the little bubble over here with seeing the 64 to the 1/6 as the 6th root of 64, write that down. And let's find our answers for x. Adding 4 to both sides, this becomes 2x equals 6. Divide by 2, we get x equals 3. Over here, I add 4 to this side. That becomes 2x equals 2. Divide both sides by 2, x equals 1. We're finished with number 6. Ready for number 7. Number 7 says the square root of 4x minus 7 plus 2 equals 5. This plus 2 is not under the radical. If it helps, put a little end to the radical sign right there. Our job is to isolate this first, so we got to get rid of this plus 2. The opposite of adding 2 is what? Subtracting. So let's subtract 2 from both sides. Now we have the square root of 4x minus 7 equals 5 minus 2 is 3. As soon as you wrote this down, I want you to notice that you have a square root here. Have an even root means at some point going to raise both sides to an even power. You have an even root here, which means at some point you're going to raise both sides to an even power. And right here is the moment it's going to happen. To undo a square root, the inverse of a square root is to take the square of both sides. In this step, we just raised both sides to an even power, which means we'll have to check for extraneous solutions at the end. So raising both sides to the second power. If you need to pause to finish writing down this note, this is a super important note, okay? Go ahead and press pause to finish writing the note and then rejoin us on the solution here. Raising both sides to the second power, the square root and the square cancel, and I have 4x minus 7 equals 3 squared is 9. We're going to add 7 to both sides. Now we're down to a two-step equation, right? Let's just finish solving here. 4x equals 16. Divide by 4. Divide by 4. And we get x equals 4. But we're not done because we have to check. So we're going to take 4 and we're going to plug it back into our original equation. So that's 4 times 4 minus 7 plus 2. Notice I'm very careful to make sure the plus 2 doesn't by accident get underneath the radical, equals 5. Please press pause here and run the check on your own. See if you get a true statement. So that becomes 16 minus 7 underneath the radical, plus 2 equals 5. 16 minus 7 is 9 underneath the radical still, plus 2 equals 5. Square root of 9 is 3, plus 2 equals 5 still. And yes, this comes out true, 5 equals 5. So you have verified that this is a real solution. It is not extraneous. In tomorrow's practice, there may be cases, hint, 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 where when you check a solution, it does not come out to be a real answer. It's extraneous. We are done with our notes. These are our 7 examples for today. I'd recommend if there were any that you weren't so sure about, take out a blank piece of paper and copy it over, put the notes to the side, and try it one more time. And jot any questions you have on the side. We'll start class tomorrow with any questions that you have on these first 7 examples. Have a great day, everybody.